Welcome to Calculus, Section 3 of Chapter 3, where we're looking for one more rule, and that's the derivative of the composition function. You'll hear me call this the chain rule. There's a reason for that. Anyway, the first thing that I want you to notice is in this problem, you could, if you really wanted to, rewrite this. I might need to remind you for a second, Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So the fact that it's to the third power, you could simplify this with those coefficients. So 1, 3, 3, 1. And then, let me switch colors for you. You look at this first term, and you start out with 2x being cubed, and then it's 2x being squared, and then it's just 2x. But then, one more color, you look at the second term, you have 3 cubed, there's a plus right here, and then 3 squared, and then times 3, again, more pluses. So the reason why I'm sharing that with you is you could simplify this is a lot of work if you ask me, to be 8x cubed. Let's see, 2 squared is 4, 3 times 3 is 9, 9 times 4 is 36. Squared, let's see, 3 squared is 9 times 6 is 54x. And I'm not double checking my math, so I hope I'm doing everything right. And then take the derivative of that. Let's see, I'll switch colors one more time. Where the derivative of that, you would say, is 24x squared plus 72x plus 54. Again, I feel like this is a lot of work. There's got to be a better way. And that's what I'm going to share with you in the next part. So this is a rule. And first of all, what is a composition function? That is, if you remember from pre-calculus, I'm just going to define it this way, as h of g of x. I just want to use different variables. So what I'm saying is that there's a shortcut for this. And what you're doing, if you're doing the derivative, is you do the derivative of the outside function, that's the h, you leave the inside function alone, times the derivative of the inside function. So let me show you what that looks like on the same exact problem. So what I need you to recognize is that there's an inner function with an outer function. So I should write that out. So look for an inner function. And usually what you're looking for are parentheses. Usually, not always, but usually. So as I look at this problem, my inner function is the 2x plus 3, and my outer function is the cubed. So what you need to do is take the derivative, this is sort of like a step-by-step process, take the derivative of the outer. This is how I say it, by the way. Leave the inner alone, and then multiply by the derivative of the inner. By the way, you'll never see this written in a math textbook. This is just my own way of doing things. So as I look at this problem, the outer function is being cubed. So what I would do is I would think, oh, well, the derivative of something cubed is 3 times that something squared. And that's where you leave the inner alone. 2x plus 3. You leave it alone inside. But then you need to multiply by the derivative of the inner. Well, the inside is, the derivative is 2. And most people just leave this problem because multiplication is associative commutative as this. Oops. 3 times 2 is 6, and then leave this alone. Now, if you actually FOILed this out, which I do want you to practice here, you get 4x squared. The outside would be 6x. The inside is 6x, so that is 12x plus 9. And what do you think will happen once I distribute this 6 to all of these? Well, 6 times 4, you can see it at the top of the screen, is 24. 6 times 12 is 72. And 6 times 9 is 54. So this rule works. Again, pause the video at any time and really soak this in. Make sure you understand. So as we move on to the next example, my clues of looking for parentheses don't really work. However, you could rewrite this function for f of theta as sine of theta being squared. And now you definitely have an inner function. So if I were doing this derivative, I'm just going to do it over here. I would say, okay, well, the outer function is being squared, so bring the 2 in front, times sine of theta, now to the first power, but you don't actually have to write to the first power, times the derivative of sine of theta. So that's cosine of theta. And from here, you can now figure out what f prime of theta is. F prime of, I knew I messed up somewhere. It's just this should have said f prime of theta because that was my independent variable. Sorry about that. And over here should say f prime of 3 pi over 4. Well, think about where 3 pi over 4 is on the unit circle. It's over here. That's at the ordered pair negative root 2 over 2, positive root 2 over 2. So now our answer to this is 2 times sine is the y-coordinate, and cosine is the x-coordinate. Well, this is nice. Well, maybe just cancel out these 2's. Root 2 times root 2 would be 2. Oh, well, another set of 2's canceled. So you're looking at negative 1. But make sure you answer the question that's being asked. We want the slope of the normal line. So the slope of the perpendicular to that. They don't ask these questions very often, so we don't really have notation for it. Slope of, alright, NL for normal line is, well, what's the opposite reciprocal of negative 1? It's positive 1. So again, pause the video before I move on to the next slide. Make sure you really understand this. So now we're going to practice a bunch of chain rules. So as I'm looking at this, do you have an inner function? Now, let's be real. Like, you could, if you wanted to, like, multiply 3x squared plus 2. Remember, being cubed means multiply by itself 3 times. But do you really want to do that over and over again, especially on a time test? Okay, so I've convinced you that this is necessary. So look for the parentheses. So your inner function is inside the parentheses. The outer function is being cubed. So bring the 3 in front. Now the new exponent is squared. And that's how you would do that derivative. Then you leave the inside alone. And then multiply by the derivative of the inside. Well, the derivative of 3x squared is 6x. And the derivative of 2 is 0, so there's no reason to write that. Now, most, I doubt a multiple choice will leave the answer like this. If it's a free response, you could leave it like that. But I want to point out that a multiple choice question will probably write it like this. So get practice simplifying, and that will make your life easier. Let's look at the next one, g of x. I hope you realize, and as you get a lot of practice, it'll make perfect sense that you write that to the 1/2 power. Review your exponent rules. So then when you do the derivative, you do the outer function's derivative first. That's bringing 1/2 in front. It's now to the negative 1/2 power, and then times the derivative of the inside, which is just times 2. So what's really nice about this is 1/2 times 2 would cancel. Don't forget that the square root is the same as the 1/2 power, and a negative exponent would put it back into the denominator. Again, please pause and really understand as we move forward. And I'm going to assume you understand if I just keep going forward. Again, think of the root as being to the 1 whatever power, your index power. And I'm going to actually do two things, because I'm just going to write it as to the 2/3 power, because if you have a power to a power, you can multiply them. Please refresh your power rules, exponent rules, I guess I should say. So your inner function is x plus 2, notice the parentheses, and then to the 2/3 power, so bring the 2/3 in front. That function is now to the negative 1/3 power. Why? Because you subtract 1 from 2/3, you get negative 1/3. You leave x plus 2 alone. Now you do want to practice the chain rule, but the derivative of x plus 2 is just 1. So you're sort of wasting time to do that, but it is good practice. So how would a multiple choice answer key be written? Is we have 2 from there. This 3 is in the denominator. The negative exponent puts the cube root into the denominator of x plus 2. That's your derivative. Looking at the next one, again, rewriting it is your friend. Don't worry that it's a capital F. Sometimes we do that, not to stump you, but to let you know you can write it however you want, to the 1/3 power. So the outer function is that 5 something to the 1/3 power. So as you bring the 1/3 in front, it becomes 5/3. Now it's to the negative 2/3 power, because you subtract 1 from the exponent. Leave x squared plus 2x alone, and then times the derivative of that, which is 2x plus 2. The derivative of the inside, I guess I should clarify. So as you are simplifying, you would probably see it written this way, and they might actually distribute it. I'm not going to distribute. But this is, a positive exponent, so it stays in the numerator, over 3. The negative exponent puts it back into the denominator. X squared plus 2x squared. So again, pause the video. Make sure you understand. I guess I should have waited a second before moving. Sorry about that. Be ready to come to class and ask questions. That's what I want. On the last two problems, what you'll notice is you actually have a chain inside a chain. I know I just mentioned that this is called the chain rule. I think it's something about links. I don't know. I didn't name anything in math. But what I'm going to give you is multiple parentheses. That this is really cosine of 3x, even though there's no parentheses there, that value being squared. So what I'm saying is there's an innermost function, and then there's like an in-between inner function, so you got to pay close attention. I stick to my guns where you do the derivative of the outermost function first. So what's the outermost is the thing being squared. So you bring the 2 in front, and now it's to the first power, which you don't have to write, so I'm writing it small. You leave cosine of 3x alone. But then you do the derivative of the inner function. Now remember, there's an outer part of the inner function, and that's cosine. Well, what's the derivative of cosine? Negative sine of 3x. And then times the derivative of that inner function, which is 3. So your final answer, we do have a negative. 2 times 3 is 6. And you can just write it like this, cosine 3x, sine 3x. And that is it. All right, I'm going to hurry and do the last one just so I can start fresh in the next slide in the next video. I'm not going to show as much work because as you get better at this, this will make perfect sense. 2, you leave sine of 2x plus 1 alone, times the derivative of sine, which is cosine of 2x plus 1, and then times the derivative of 2x plus 1, which is 2. Notice that you don't have to write sine to the first power after you change that exponent. The only way to simplify this is to put a 4 in front. And the video is going to end. So join me in the next one.